In this video, we are going to talk about complex numbers. The idea of complex number emerges from the fact that quadratic equation x square plus 1 equals 0 has no real roots, because when we write x square equals minus 1, we get absurdity because square of a real number is non-negative. But what we get here is square of a real number x negative. Therefore, a new number has been introduced, which will be the square root of this quadratic equation x equals plus minus square root of this minus 1, and it is represented by I, and it is called iota. So therefore, a new number system which is not real makes use of square root of minus 1 or iota I. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. What is the standard form of a complex number? A number in the form x plus iy, where this x and this y are real numbers and this I is iota, which is square root of minus 1. So x plus iy is the standard form of a complex number, and it is denoted by z. In this x is called the real part and this y is called imaginary part of the complex number. If x is 0, the complex number z will be iy, and it is purely imaginary, and when y equals 0, then z will be x, which is purely real. So z equals x plus iy is the standard form of a complex number. For example, complex number 6 plus 5i is in the standard form, whereas complex number 3 minus 2i upon 2 plus i is not in the standard form. How two complex numbers are added and subtracted? If complex number z1 is x1 plus iy1 and z2 is x2 plus iy2, then z1 plus z2 will be sum of the real parts x1 plus x2 plus sum of the imaginary parts y1 plus y2 into I. z1 minus z2 will be subtraction of real parts x1 minus x2 plus subtraction of the imaginary parts y1 minus y2 into I. Next, we will see how two complex numbers are multiplied. z1 into z2 will be x1 plus iy1 into x2 plus iy2. This will be x1 into the second bracket plus iy1 into the second bracket. This will be x1 into x2 plus x1 y2 into I plus x2 y1 into I plus y1 y2 into I square. This will be x1 x2 plus x1 y2 plus x2 y1 into I. Here this I square will be root minus 1 square, that will be minus 1. So using minus 1 for I square, here it will be minus y1 y2. So finally we get z1 z2 equals x1 x2 minus y1 y2 plus x1 y2 plus x2 y1 into I. In equality of complex numbers, two complex numbers z1 and z2 are equal when their real parts are equal and their imaginary parts are also equal. For example, when x plus iy is 3 plus I root 5, then this x equals 3 and this y equals root 5. Since a complex number z equals x plus iy consists of a real part and an imaginary part, there is no order relationship between two complex numbers z1 and z2. They are either equal or they are not equal. These are the only relationship that exists between them. If alpha plus I beta is 2 minus 3I, we have to find the values of alpha square plus beta square and alpha cube plus beta cube. Equating real and imaginary parts, we get alpha equals 2 and beta equals minus 3. We have to find alpha square plus beta square. Alpha square plus beta square is alpha plus beta whole square minus 2 alpha beta, because this alpha plus beta whole square gives us alpha square plus beta square plus 2 alpha beta and minus this 2 alpha beta. After cancelling these 2 alpha beta, we get alpha square plus beta square. Now we will substitute the values of alpha and beta and write 2 minus 3 whole square minus 2 into 2 into minus 3. This will be minus 1 square 1 plus 12. So alpha square plus beta square is 13. Next we find alpha cube plus beta cube. From sum of two cubes, we have alpha plus beta cube minus 3 alpha beta into alpha plus beta. After substituting the values 2 minus 3 cube minus 3 2 into minus 3 into 2 minus 3, this will be minus 1 cube minus 1 minus into minus plus 3 2s are 6, 6 3s are 18 into minus 1, that will be minus 1 minus 18 minus 19. So alpha cube plus beta cube is minus 19. Next we will see conjugate of a complex number. X minus iy is called conjugate of x plus iy, and x plus iy is called conjugate of x minus iy. For obtaining conjugate, we only have to change sign of the imaginary part. So here plus has been changed to minus and minus has been changed to plus. If x plus iy is complex number z, then its conjugate x minus iy is denoted by z bar. So therefore, if z is 3 plus 2i, then its conjugate z bar will be 3 minus 2i. Or if z is minus 3 plus 2i, then its conjugate z bar will be minus 3 minus 2i. Remember, here we have changed the sign of the imaginary part only, whereas the sign of the real part remains the same. On the same counts, if z is minus 4 minus 5i, then its conjugate z bar will be minus 4 plus 5i. Here sign of the imaginary part only changes while sign of the real part remains the same. If complex number z is x plus iy, then its conjugate z bar will be x minus iy. If we add them, it will be z plus z bar equals x plus x 2x, which is real. So real part x will be z plus z bar upon 2. If we subtract them, z minus z bar will be 2iy, which is imaginary due to presence of this I, and the imaginary part will be y equals z minus z bar upon 2. Now z into z bar will be x plus iy into x minus iy, that will be x square minus I square y square, that will be x square, and since this I square is minus 1, z into z bar will be x square plus y square, which is real. So what we get here is sum and product of two complex conjugates are real and their difference is imaginary. We have to find the standard form x plus iy of the given complex number 2 minus 3i upon 3 plus 2i. In order to write this complex number in the standard form x plus iy, we have to make this denominator real. For that, we will multiply given complex number in the numerator and denominator by the conjugate of 3 plus 2i, that is 3 minus 2i upon 3 minus 2i. Now we will multiply numerator and denominator separately. So in the numerator it will be 2 multiplied by 3 minus 2i minus 3i multiplied by 3 minus 2i upon 3 plus 2i multiplied by 3 minus 2i will be 3 square, that is 9, minus 2i square, that will be 4i square, but since I square is minus 1, this will be plus. So in the next step will be 6 minus 4i minus 9i minus 3i multiplied by minus 2i. It will be plus 6i square, but since I square is minus 1, it will be minus 6 upon 13. Now 6 minus 6 will be 0, and we get minus 13i upon 13, that will be minus I. So the standard form of the given complex number will be minus I. We will see how to express 2 plus 3i upon 1 plus 2i into 3 minus I. First we will solve the denominator. We write 2 plus 3i upon 1 into 3 minus I, 3 minus I, plus 2i into 3, 6i, 2i minus I minus 2i square, but since I square is minus 1, it will be plus 2 equals 2 plus 3i upon 5 plus 5i equals 2 plus 3i upon 5 into 1 plus I. Next we will multiply by conjugate of 1 plus I in the numerator and denominator and write 2 plus 3i upon 5 into 1 plus I multiplied by 1 minus I upon 1 minus I, which is conjugate of 1 plus I. Next we will multiply numerator and denominator separately. In the numerator, 2 into 1 minus I plus 3i into 1 minus I upon 5 multiplied by this 1 plus I multiplied by 1 minus I will be 1 square, that is 1, minus I square, that is minus 1. So this will be 1 plus 1 equals 2 minus 2i plus 3i minus 3i square, but since I square is minus 1, this will be plus upon 5 2s are 10. Now here the denominator is real, therefore we can express this complex number in the standard form x plus iy. So next 5 plus I upon 10, that will be, after dividing separately, 5 upon 10 plus 1 upon 10 I. So the standard form will be 1 upon 2 plus 1 upon 10 I. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.